My name is Nidhi Prakash, and this is our Elements of Financial Management Experiential Learning Project. Our topic is Collaborative Stock Recommendation System. This is our team detail. This is the presentation overview and introduction. Investors in financial markets are constantly seeking effective tools to aid in their stock investment decisions. Traditional stock recommendation systems often rely on historical performance and market indicators, but these methods may not fully account for individual preferences and the complex nature of investor behavior. This project aims to develop a collaborative recommendation system that leverages the collective preferences of investors to recommend stocks, providing personalized investment suggestions. Using collaborative filtering techniques, the system seeks to enhance the investment decision making process, ultimately helping investors make more informed choices based on the preferences and behaviors of similar investors. So, based on this, we have come up with a problem statement, which is to develop a solution that utilizes collaborative filtering techniques to provide personalized stock recommendations based on the collective investment behaviors of similar investors. Traditional approaches may rely heavily on historical performance, like I mentioned, and market indicators. So, this limitation can result in recommendations that do not align with individual investor preferences, potentially reducing the effectiveness of the recommendations. So, thus, the problem is that we need to address this need for most personalized and collaborative approach, and thus we develop the project.
Hello, I'm Shreyas, and I'll be talking about collaborative filtering and the objectives of this project. So, collaborative filtering technique is a method that uses information from multiple users to automatically predict a user's interest. It works by analyzing how similar users have interacted with items to recommend them to other users. So, collaborative filtering uses a matrix to map user behavior for each item in its system. The system then draws insights and values from this matrix to plot as data points in a vector space. So, various metrics are used to measure the distance between points as a means of calculating user and item similarity so that it could be recommended for other similar users. So some of the key points of collaborative filtering are user-based recommendations. So collaborative filtering works by finding users with similar taste to a given user and recommending items that those similar users liked. Item-based recommendation, it can also work by identifying items that are similar to items a user has liked in the past and recommending those similar items to the user. Data driven. So the approach relies heavily on large data sets of user interactions such as liking a post, clicking a particular video, or the purchase history or the watch history of the user to make accurate decision on these insights. Cold start problem. So cold start problem is a problem where there is a difficulty and ineffectiveness in a recommendation for new users or items due to the lack of sufficient data needed for uh, drawing the insights. Simplicity and effectiveness. So, uh, collaborative filtering being very simple uh, is very highly effective and widely used in various platforms for recommendations, such as Netflix to recommend uses it to recommend movies. Amazon uses collaborative filtering techniques to recommend products to the buyer, and Spotify uses collaborative filtering for the to recommend music from by drawing insights from similar users. So the objectives of this project are developing a collaborative filtering model. So creating a model that uses collaborative filtering technique that uses the insights of similar uh, users to recommend different stocks and predict user preferences. Improved investment. decisions, enhancing decision making for retail and institutional investors by providing tailored stock recommendations, incorporating multiple data sources, integrating financial indicators such as news, sentiment, social media trends, and market trends, and user behavior data to enhance the recommendation accuracy and effectiveness, ensuring real-time recommendation updates. So, taking care of the dynamically updating real-time data such as change in stock prices, market trends, and the political behavior of the nation to make the recommendation more dynamic and effective. Evaluating model performance, accessing the recommendation accuracy using metrics such as mean absolute error, root mean squared error, and precision at k. Thank you.
Hello, I'm Vinayak. Now I'll be talking about the methodology which we use for our project. So the first thing which we did was prepare the data set. That is, we gathered the company data and the investor data, and we clean, collect, and pre-process the data set, which will be used for further processing. Then we built the model using neural networks. That is, we used PyTorch to build a neural network model for predicting the stock preferences based on the investor interactions. Then, in order to evaluate the model or check how good our model is, we used metrics like MAE, precision, recall, NDG to ensure accuracy and relevance of whatever the recommendations our model is providing. Then, testing. We tested it on a lot of test cases based on whatever data set we had taken, and we provided checked the personalized stock recommendations for each of those recommendations. Then integration, we integrate it with the real world data and validate its effectiveness, and also it also helps us to improve the accuracy of our model to check and to also to see how relevant our model and its predictions are. Now let's look at a sample implementation of our project and how it works. For example, we have the company data like this. You have the company ID, the name of the company, the size, how much profit it's making, and which industry it's working in. Then you have the investor data like this. You have the investor ID, then you have the name of the investor, then you have something called risk tolerance. These are all the factors which should be which our model will be taking into consideration when it's providing what the recommendations. Basically, that's what the collaborative filtering refers to. Here, it takes the preference of the user and also all the people similar to him, and based on their preferences, it gives the stock recommendations. For example, here risk tolerance. Some people might have high risk tolerance, others might have low risk tolerance, and others might not like reward. They are not like, I don't want to take the risk also, I want to take this, so they'll be moderate. Then the time frame which you're looking for example, some might invest for short term, others might invest it for long term. Then the income needs also, whether he is depending on this one or he has some other sources of income or it's just a side thing which he's doing. Then you have the liquidity needs, whether he needs money to be liquidated right now or some other time, or if he's in urgent need of liquidation or not. Then we also take into consideration the tax consideration, whether the tax is applicable or not. Then you have the type of account, whether it's a taxable account or not taxable account. Then you have the age of the investor. Then you have the how much experience he has, whether he is experienced, he's novice, or he knows something like that. Then you'll take into look at the amount of other assets which he has, whether he's only depending on the stock money earned through the stock market or he has some other sources of income. Then lastly, the risk capacity, that is the amount of risk he can handle, like whether he has a capacity to take high risk or low risk or moderate. So based on this, all this what factors are taken into consideration. Then based on this, our model gives the recommendation. For example, what you do is you give the input as an ID of, like for example, suppose you say your preferences matches with some one of these, so you give that as a what input, and based on your preference and all other preference in the data set, it gives you the recommendation. For example, here if you select one of the IDs, you'll get this like for example, you get these are all the stocks which are recommended by our model. You have the company name, company ID, size, and profit. So basically, based on your preference and people who are similar to you, these are the stocks that is recommended, or you can look into the stocks to purchase it. And these are also the then here are the accuracy like what results of our other metrics which I told about before to test the accuracy. So yeah, this is how it generally works. Later, we'll be showing you a demonstration of how our thing works also. Then, so the conclusion is going to be, say, like this collaborating recommendation filtering has very high potential because it helps you what better your investment decision making in the stock markets, and which basically helps you to reduce your risk. So it's going to be really important, and it can has a lot of what potential within it. So since our model, we have created a model ensuring high accuracy and transparency, and also it has insurance against high market volatility. So we feel that it has very huge potential, which, if utilized properly, can help a lot of people and reduce the market risks associated with it. So yes, thank you.
Yeah, so we are going to talk about collaborative recommendation for stocks at any sort of company which can be used for recommending stocks to their customers. We have used Python and we are using scikit-learn to train the model. We have data which is divided into three different formats. One is the data of the companies, which is size, profit, and industry. And the investor data is divided into uh, 10 fields, which is the ID of the investor's name, the risk tolerance for the investor, time horizon, which is short term or long term, income needs, liquidity needs of the investor, the tax consideration of the investor, and if the account type is taxable or non-taxable, age of the investor, investment experience, which is novice experienced, or other assets which the investor owns, and the risk capacity of the investor, which is low and high or moderate. Mapping is what a particular investor prefers in this so and so company. So that is what mapping is. It maps the preferences of investors with ID 1 and the company ID, which is from this particular table. So now, okay, yeah. So we are using CUDA if CUDA is available. If it is not available, we are using the CPU itself. Now, in the collaborative filtering model, we are having in the class, we are having two methods. One is the forward method, which is used to train the model. The other one is the init function, which is a constructor, which is called when the class is initiated. Uh, and then we are training the model for 18 inputs. Uh, right, so we'll be running the model. And when you train it for 18 epochs, it takes over 20 minutes. So we'll be running it for 5 epochs only. It is training for 5 epochs, which will give us an accuracy of almost 75%. If it is trained for more than 20 epochs, it is giving us an accuracy of 89%, which you can see in the accuracy which we have got here. It is trained for 2 epochs and the current loss is 33. The previous epoch's loss was 28.14. The third epoch's loss is 3.6, which is very less and is highly beneficial for us. The fourth epoch loss is 6.54. Now, finally, the fifth epoch's loss will be available in just a few more seconds, which is 6.21. Now, we'll be moving forward and trying to recommend stocks to a particular person based on their customer ID on which data has been trained. Uh, so this is loading a model from a path if we are going to use it in case. We are not going to save the model. So as we just trained the model, uh, it is telling for the investor of ID 6. And if you want 7 recommendations to be made, these are the companies which it is recommending to that particular investor. Now, say I enter the user ID as 25 and the number of companies needed as 3. Using the model which we have trained, uh, it will recommend 3 companies, which is company ID with 6312, 12019, and 23023. This is how it has recommended using collaborative filtering system. Uh, Moving on.